guys, good morning. All right, so I'm filming this ahead of time. I got to figure out what day you're watching. This is for Wednesday. Happy Thursday. So if you're watching this video, hopefully yesterday you did Wednesday's Fantastic Five. And then the idea is that you're watching this video right now to see me go over yesterday's questions, which should help you solve your questions for today's Fantastic Five. So if you're following the order of, I guess the list that I have in your Canvas announcement, you should be watching this video, and then immediately after, go and do today's Fantastic Five. So anything you see in this video, if you want to take notes, that's probably going to be a good idea, just like you would do in class. Anything you see me do that you think might help you solve another question, jot it down in your notebook, piece of paper, anywhere you can. That way you can use it to try and improve your score for today and then moving forward the rest of the week. When I made this Fan 5, I knew it was going to be a little challenging. One, just because you've been out of school for a couple weeks, and I've definitely put some stuff on here that you maybe haven't seen before. And that's important to me because I think with what we're going to do this 9 weeks, it's all going to be fractions. Some of the stuff's pretty challenging. So, to see it in Fantastic Five and get a little bit of that extra practice is pretty helpful. But with that being said, I do think everybody should have been able to get at least one or two of these questions correct. Some of them we have seen in Fantastic Five before. Now, it's a little bit different if you're new. If you're new to our class, you may not have seen some of this stuff, so that's a little bit different. Ultimately, I don't care what your score was. If it was a 0 today, watching this video ought to help it go up to a 1 or a 2 or a 3, whatever it might be. And since we're only doing Fan 5 3 days this week, they're probably going to be similar questions next week. So our quiz won't be this Friday, it'll be next Friday. But obviously with having 8 days instead of 3, I will make them a little bit more challenging next week. So I'm going to stop running my mouth. I'm going to get right into it. Number 1 is one of those questions that I thought, and again, I'm filming this ahead of time, so I don't know if we did or not, but I do think number 1 is a question where I think we should have some pretty good scores or some pretty good numbers. It says to convert, which we talked about means change, convert 12/7 to a mixed number. Now, with the fraction 12/7, that has a special name because normally our numerator is smaller than the denominator. But in this case, it's flip-flop. Our numerator, which is our top number, is bigger. So we have always called this an improper fraction. So when you think of just a normal, like if this was switched 7/12, that's a proper fraction. That's what we're used to seeing. But with your numerator being bigger than your denominator, this is an improper fraction. So we got to change that. If you remember, fraction bar means divided by. So we can read this as 12/7, but we can also read it as 12 divided by 7. That's how we're going to find our mixed number. And remember, when we're talking mixed number, we got to have two things, a mix of two things. We've got to have a whole number, and then we have to have a fraction as well. So if fraction bar means divided by, and I'm looking at this as 12 divided by 7, I've got to figure out how many times can 7 go into 12. Doesn't mean it's going to go evenly, but I want to get it in there as many times as I can without going over. You guys are pretty good with your multiplication. 7 times what is going to get me close? Well, guys, 7 can go into 12 one whole time, which means 1 will be my whole number. Okay, here's where you got to kind of think, okay, if I did 7 times that 1, it gets me to 7. I'm trying to get to 12. I got to figure out what's left. What's my remainder? So if I can get to 7 and I'm trying to get to 12, that gap right there is 5. My remainder would be 5, which becomes my numerator. Once you've got your numerator, your denominator is not going to change. Whatever you've got over here, you're going to bring it over to the side. If I took 12/7 improper fraction, converted that to a mixed number, I should have had 1 and 5/7, which would have been B. Just real quick, I can show you another one really quickly. Let's just say my improper fraction is 9/4. My numerator is bigger than my denominator, so I know it's improper. So again, fraction bar means divided by. How many whole times can 4 go into 9? 4 times what is going to get me close? If you know your facts, I know that 4 can go into 9 2 whole times, because 2 times 4 gets me to 8. When I'm trying to get to 9, whatever that gap is, my remainder, that's going to become my numerator, which would be 1. Denominator doesn't change. So if I took 9/4, converted it to a mixed number, that would give me 2 1/4. I think even if you did miss that one today, you might see that and say, oh yeah, I remember doing that. And even if it's the first time you've seen it, again, for our new people, it's something that you just see it once, maybe practice it a couple times, and you should be able to get that either tomorrow or Friday. So that one should be one to help improve our scores. And if you can do number 1, it's going to be really helpful for the next one, number 2, because they do kind of go together, but this one we've never done before. So now it says convert 4 2/3 to an improper fraction. So now that's the opposite. I have given you a mixed number because it's got a whole number and a fraction. I've given you 4 2/3. And you've got to do something to that mixed number to make it improper. Again, going back to number 1, an improper fraction is just going to be a fraction where your numerator is bigger than the denominator. So, and this is also similar with, you just maybe have to see it once or twice to be able to do it. There's 2 steps here. If I have 4 2/3 and I want to convert that to a mixed number, I start down at the bottom. At the bottom, I will multiply. At the top, I will add. One more time. At the bottom, I will multiply. Oops. And at the top, I will add. What I mean by that is, first thing I'll do is I'll start with my denominator, and I'm going to multiply it by my whole number. 3 times 4 gives me what? 12. Once I've got 12, because I did 3 times 4, I got 12, I will then add my numerator, 12 plus 2, which gives me 14. And just like in the previous question, my denominator does not change. That will change to 14/3, which is C. Okay, and I'm going to show you a way to check that in just a second, but let me just give you another one really quickly. If I gave you the mixed number 2 3/7, and I wanted that to be an improper fraction, at the bottom I will multiply, at the top I will add. Multiply, add. Multiply, add. So if I multiply my denominator by my whole number, 7 times 2 gives me 14. And if I add that numerator, 14 plus 3 gives me 17, denominator doesn't change. That would be 17/7. So it's just like a little cycle. You multiply, add, multiply, add. Now, going back to my answer, I had 4 2/3, and I realized that converted to 14/3. You can check that, because look, we've got our improper fraction. I can switch that right back to a mixed number to make sure it matches. We just did that on number 1. Fraction bar means divided by. How many whole times can 3 go into 14? 3 times what gets me close? Well, it goes in 4 whole times, because 3 times 4 gets me to 12. When I'm trying to get to 14, that leaves me a remainder of 2, and my denominator doesn't change. If my mixed number that I started with matches right here when I check, obviously I know I got that one correct. I can do the same thing on number 1. Like on number 1, it gave me, 12/7, which I converted that to 1 5/7. Well, I can take my mixed number and I can change it back to an improper fraction. Because remember, at the bottom I would multiply, at the top I would add. 7 times 1 gives me 7, plus 5 gives me 12, and the denominator doesn't change. If my improper fraction here matches the improper fraction that I get when I check it, I know I'm right. So those two questions work together, and I I know it's kind of newish to you, so I'm not expecting them to be perfect tomorrow. But maybe by Friday, if you're getting number one right, you should get number two right, and vice versa. Though you shouldn't be getting one or the other, because if you check it, you'll get it right every single time. Pretty similar to like when we were doing those interpreting remainder questions. If you would just check your work, you'll get the answer right. So 1 and 2, maybe a little bit challenging today, or sorry, yesterday, but I think for the next 2 days, they should get a little bit easier for you. All right, number 3, speaking of interpreting remainders, this is another one where we spent some time on it in class. We've had it in Fan 5. If you follow the steps and do kind of what we've been doing, I think this is one you could get right. So it says, there are 9 pieces of gum in each pack of Orbit. If I want to give each of my 235 students 1 piece, how many packs will I need to buy? So a lot of things you can kind of break down here. The main keyword to me that stands out is each, which we know can mean I need to be either multiplying or dividing. And if you look at your answer choices, logically, you can tell, hey, I'm definitely going to be dividing here because all my answers are getting smaller. So we would set this up, 235 divided by 9. Dangerous monkey swipe bananas. And we just start with our division. Now we know 9 cannot go into 2, but we know it can go into 23, and it goes in twice. Because if I did 9 times 2, that would give me 18. And then I'd have to do a little bit of regrouping to do my subtraction. But if I did 23 minus 18, that would leave me with 5. And then I would bring down my 5. Once I bring down, I start all over. Now I'm looking at my division again. How many times can 9 go into 55? Again, you kind of have to know your facts here, but 9 goes into 55 6 times because 9 times 6 would give me 54. And if I subtracted 55 minus 54, that would leave me with 1 with nothing to bring down. So my answer is not just 26, it's 26, remainder 1. But the one thing we always talk about, if you went to the store and you said, hey, I need to buy 26 remainder 1 packs of gum, they would look at you like you're crazy. It's not a real thing. So we've got to interpret the remainder. Right now, we could get 3 possible answer choices. I could ignore the remainder and get 26. I could use that remainder to push up and have 27, or I could use the remainder as my actual answer, and it could be 1. That right there already eliminates an answer choice. 25 should not be on there. So these numbers right here, they represent packs of gum. I'm either going to have 26 packs with 9 pieces in each, 27 packs with 9 pieces in each, or 1 pack with 9 pieces inside of it. Logically here, I could probably go ahead and get rid of an answer choice because, guys, if I got to but if I got to give 235 people a piece of gum, 1 pack's not going to come even close. That's going to be 9 people. There's going to be a lot of people that not get what they need. So I could go ahead and get rid of that one as well. So that leaves me with either 26 packs or 27 packs. Here is where I was saying, if you just check your work, one of them you'll be able to eliminate because it's not possible to answer your question. So I don't know those off the top of my head. That's why I would stack them up. This is a lot easier. I don't know why that happened. A lot easier if you know your multiplication facts, which is why we work on it so often. All right, so starting with 26 times 9, I would do 9 times 6, get 54. 4 stays, 5 goes. 9 times 2 is 18, plus 5 gives me 23. All right, over to 27 times 9. 9 times 7 gives me 63. 3 stays, 6 goes. 9 times 2 is 18, plus 6 gives me 24. So right here, logic, just got to think, guys. If I got to give 235 people a piece of gum, only one of those answers makes sense. If I bought 26 packs of gum, that would be able to provide gum for 234 people. That's not enough. That's not what my question needs me to do. Because if I have one person not getting gum, I didn't do what I was supposed to do. So that's when I would go back to the store. I'd get that extra pack of gum. And even though I would have more pieces than I need, in this case, you would rather have more than not enough. It couldn't be 26. It would have to be D, 27. Oh no. I really hope that did not all just go away. Do I keep going? Yeah, I'm going. Man, I hope that didn't just stop recording. Okay, we'll figure out in just a second. I don't remember where I was. I think I was saying it had to be 27 packs because if I did 26 packs, it just wouldn't be enough. 27, I'd have more than I need. That's okay. So that one would be D. Man, I really hope that didn't mess up my recording. All right, moving on to number 4. This is another one where we had never seen it before. There is a way you could have done this and gotten it right, but it won't work every time. So I'm just going to show you the way that I would really like you to do it. And once again, knowing your multiplication facts is going to come in huge with this. So it says, which answer choice below shows 12/16 in simplest form? So one thing of many that we're going to do with fractions is we're going to be able to simplify them. And I guess the way I kind of like to think of it is if you could do something the easy way or the hard way, I think most of you would probably like to make things easier for yourself. I'm pretty similar with that. If I had a simple option or a really, really challenging way to get something done, I'd like to make it maybe the easier path to travel. So when I think of simplest form with a fraction, it's not as necessarily simple, but I kind of make it think like it's the smallest way that I could look at it, the smallest way that I can use my eyes to represent that fraction. Because with the numbers 12 and 16, if I had to make a fraction with that, that would be a lot of different pieces. And it's not really an easy picture for me to draw, but if I can maybe draw it using less pieces, that's something I would want to do. So if we are ever going to simplify a fraction, a couple steps we got to take. First thing I'll always do is I'll just write the fraction. And what I have to do now is I have to list every factor for my numerator and every factor for my denominator. So this goes back a while to more review. When we're talking factors, we're talking about the numbers that we can multiply to get 12 and to get 16. So let's just start with the numerator. Let's start with 12. And really you're just listing factor pairs here, and you can kind of go in order of how you would normally do it. Like if I was listing my first factor pair for 12, I would do 1 and 12. 1 times 12 gives me 12. All right, then I would try 2, and I know 2 is going to work because 12 is an even number. 2 times what would give me 12? That would be 2 times 6. All right, and then there is one more factor pair for 12. I could do 3 times 4 to get 12. Boom. Boom. Now, you don't have to have them in order. It makes it so much easier if you do. So if you have to like write them to the side and then put them in order, do that. Because again, it's going to make it way easier to look at. So I've got all my factors for 12. I'm going to do the same thing for 16. All my factors. What can I multiply to get 16? Well, I'm going to start with 1 and 16. All right, 16 is an even number. I know 2 is going to work. I could then go 2 times 8. And there is one more factor pair. I could also do 4 times 4. So if I have 4 times 4, I just need to list it once. It won't matter if I put it twice. All right, that's step number 1. Once I have got all my factors written out, I have to look for something called the GCF. That means the greatest common factor. That means I got to find the biggest number that they both have in common. And common is the most important part, because like if I look down at 16, 16 is the biggest number I have, but it doesn't mean anything to me because 16 is only on the bottom. It's not up top. I need to have a number at the top and the bottom that they have in common, the biggest one. Now look, they have 2 in common, but that's not my GCF. There's a bigger number they both have in common, which is 4. So my GCF is 4. That's step number 2, identifying that GCF. The third and final step is I have to take that GCF and I have to divide my numerator and my denominator by it. So I got to take 12 divided by my GCF of 4, 16 divided by my GCF of 4, and that is going to give me my simplified fraction. So if I did 12 divided by 4, that would give me 3. And if I did 16 divided by 4, that would give me 4. That leaves me with 3/4, which is my answer. Now I'm going to go a step further, and gosh, this is just like a lot of the questions on here. I'm going to show you a way where you know you are not going to miss this question. Once you get that answer, 3/4, you can try to simplify that fraction. Let's say I did that. 3/4. Again, if I'm going to simplify, I'm going to list all the factors, find the GCF, divide by that GCF. All right, so with 3/4, my only factors are 1 and 3. And with 4, I can do 1 times 4, and I can do 2 times 2. Now, when I'm finding this GCF, you'll notice that the GCF is 1. If you have a GCF that is 1, that means that fraction is already in simplest form, which means 3/4 is as small as I can go, which makes 3/4 the answer. Now, with 12/16, some people, give me 1 second, I'll list my factors again. Let's say that somebody thought, ooh, my GCF is 2. Maybe they forgot 4 down here. They said the GCF was 2. Well, if they did that, that would simplify down to 6/8, which is an answer choice. But that's wrong because that's not as simple as you can get. That can get smaller. That's why I like to check, because if I listed the factors for 6 and 8, my GCF right here is 2. That means I can simplify again. If the GCF was 1, I'd be done. But then I could take 6 and 8 and multiply them, or I'm sorry, divide them by 2, and that would take me down to 3/4. So there's a way where even if you make a mistake, you can keep checking or simplify twice to get to your answer. But it's just a matter of whether or not you're going to take the time to do it. So that's one where I would assume it's going to take us a little bit of practice. In class, we're probably not even going to do that till next week. And you guys are seeing this before maybe a normal 4th grader might. So the fact that we're doing this ahead of time is good. It's good for extra practice, but that's something we're going to spend a pretty good amount of time on in class. Last but not least, number 5, this is another one where I thought we should do pretty well on this one, because we've done this one probably more than any of these questions in Fantastic 5. It just says, which fraction below is equivalent to 3/5? Remember, when we're talking about equivalent, we're talking about equal. And when we have found equivalent fractions in class, some of you guys call it the butterfly method. I like to show you the cross multiplication. But really, all you had to do is you had to take 3/5. You just had to compare it to every answer choice. Again, it's just a matter of if you're willing or not to take the time to stack them up next to each other and do that work. Because, guys, it's just multiplying. This is not something that's super hard for you guys. It's just an effort thing. You just got to take it, you got to multiply, you got to stack them. So I like to go ahead and put my X in the middle there. We go bottom to top. We'll start with 6/8. 5 times 6 gives me 30. 8 times 3 gives me 24. I can look at those two numbers and see they're not the same. I can go ahead and eliminate A. Then we'll try 4/10. 5 times 4 is 20. 10 times 3 is 30. Again, those numbers do not match. They are not equivalent. Then we'll go to 12/20. 5 times 12 gives me 60. 20 times 3. If you don't know that off the top of your head, it doesn't matter. 20 ends in 0. You could have done 3 times 2 and gotten 6 and added that 0 at the end. Very clearly, those numbers are, or those fractions are equivalent, even though they look completely different. They represent the same amount. And last but not least, with 1/2, if I did 5 times 1, it would give me 5. 2 times 3 would give me 6, and I could eliminate that one. So that one kind of eases into the finish. We've seen quite a few of those, but again, whether you call it butterfly or cross multiplying, if you're trying to find an equivalent fraction, you can always just put them next to each other to compare them. So I know that one, or I know that's a pretty long video, but guys, normally in class, when we go over it, Monday's always, or Tuesday's always the day that takes the longest. So this video is going to be much longer than the video tomorrow and Friday, or yeah, whatever day. So I don't know what I'm talking about. But I'll have a video for every set of questions. So hopefully watching this is going to help you out with the 5 questions you're about to do now. And again, once you do those 5 questions, there'll be a video on Friday that you can watch and see me go over those. But as always, if you have questions, obviously, guys, I'm here to help. just reach out, let me know. Good luck on your Fan 5. I'm looking forward to seeing those numbers.